On July 28th, the Model Context Protocol published a new release candidate. The announcement includes a stateless core, first-class extensions, MCP apps, tasks, enterprise-managed authorization, and several protocol-level improvements. But the important story is not the number of features. It is that MCP is moving from a tool connection protocol toward a distribution layer for AI capabilities. Start with the foundation. The core protocol can now operate without a long-lived session. Earlier, MCP flows often looked like a persistent conversation. The client initialized a connection, negotiated capabilities, and then sent requests within that session. That model worked naturally for local tools and desktop clients. At cloud scale, however, session state creates operational cost. Load balancers need affinity. Containers need recovery logic. Elastic scaling becomes more complicated. The new candidate allows a client to send a JSON RPC request and receive a JSON RPC response without a mandatory handshake or persistent session. This is more than one fewer API call. It lets an MCP server fit more naturally into standard HTTP infrastructure, serverless functions, and edge networks. A capability can be replicated across instances instead of being tied to one process. Traffic can be routed, limited, observed, and scaled using patterns that web infrastructure already understands. For companies trying to serve many AI clients, that is a distribution prerequisite. The second structural change is that extensions are now first class. As an ecosystem grows, putting every new capability into the core protocol makes the core heavy and slow. MCP is separating a stable connection layer from capabilities that need to evolve faster. An extension can have its own version and lifecycle without forcing the entire protocol to move at the same speed. That gives client makers and server builders a cleaner contract. The core remains small. The experience layer can experiment. MCP Apps is the most visible example. Traditionally, a tool returns text or structured data, and every client decides how to present it. One client builds a table, another builds a form, a third shows raw JSON. Apps allows a server to provide an interactive user interface with the tool result to clients that support the extension. A travel service could return an itinerary interface. A data service could return a filterable dashboard. An operations tool could return an approval panel. The capability provider does not need to rebuild the same interface for every AI host. The key idea is not put a website inside a chat. The key idea is a portable interaction contract. The client still controls the security boundary, permissions, resources, and communication channel. The server can express the interaction that makes its capability useful. That division of responsibility is what can turn an integration into a reusable product surface. Tasks solves a different but equally important problem. Real work is often asynchronous. Research, video generation, migrations, data processing, and software builds may take minutes or hours. If a protocol only supports immediate responses, every vendor invents its own job system, or the client simply waits without reliable state. Tasks gives long-running work a trackable life cycle. A client can create a task, inspect its status, wait for completion, and retrieve the result. That changes what an agent can promise. Without task state, an agent can issue a command. With task state, it can manage delivery. It can tell the user whether work is queued, running, blocked, or complete. It can recover from a client restart. It can connect multiple asynchronous steps without pretending everything is instantaneous. For production agents, this is not a cosmetic feature. It is the difference between triggering work and owning an outcome. Enterprise-managed authorization addresses the adoption boundary inside companies. Consumer tools can ask every user to authorize every service independently. Enterprise systems need centralized identity, policy, access control, and audit. The extension allows MCP clients and servers to work with an organization's existing identity provider and authorization rules. Employees do not need an isolated account for every server. Administrators can control who is allowed to invoke a capability and under what policy. This matters because enterprise buyers do not only ask whether a tool can act, they ask who acted, with which permission, on behalf of which organization, and whether the action can be audited. An ecosystem cannot move from personal productivity into core business workflows without answering those questions. Managed authorization brings MCP closer to the identity architecture companies already trust. Several smaller protocol changes reinforce the same direction. Requests can carry the MCP method and server name in headers, which can help gateways with routing, rate limits, and observability. List responses can include a time-to-live value, so clients do not repeatedly fetch catalogs that have not changed. The remote protocol is converging further with familiar web infrastructure. These details are less visible than apps, but they determine whether a system is operable in production. Now put the pieces together. In the traditional product model, a company builds a complete application: an interface, an account system, a task engine, deployment infrastructure, and the underlying capability. The user must discover and open that application before receiving value. In the emerging MCP model, the capability can be packaged as a server and then discovered, authorized, invoked, and displayed inside multiple clients. The interface and the capability begin to separate. That creates a different distribution strategy. A company may not need to win another chat interface to reach users. It can become a capability supplier behind many interfaces. The strongest position will not come from a thin wrapper. It will come from proprietary data, execution infrastructure, trusted workflows, domain permissions, or a service that reliably completes valuable work. MCP can make that capability portable, but it cannot create the underlying value. For founders, the first question is therefore about defensibility. If the product is only a prompt inside a chat window, a client update can absorb it. If the company owns a unique workflow, a data advantage, or the right to take an important action, packaging that value as a reliable MCP server may expand distribution. The second question is product architecture. Which calls should be stateless? Which long jobs require tasks? Which results benefit from an app? Which customers require enterprise-managed authorization? The third question is observability. When 10 clients invoke the same capability, the server needs to know where a request came from, which protocol and extension versions were used, whether catalog data was cached, and where a task failed. Distribution without observability creates support chaos. The protocol improvements around headers, caching, and task state are part of the product, not merely implementation detail. There is also a reason to stay disciplined. This is a release candidate. It does not mean every client, SDK, and enterprise environment supports every extension today. Do not rebuild a stable product around an announcement alone. Choose one valuable capability and run a compatibility experiment. Separate business logic from session state. Give long work an explicit lifecycle. Document the authorization boundary. Test against real clients, not only a local demo. Design fallbacks. If a client does not support apps, return useful structured data. If tasks is still experimental in a target environment, keep the existing asynchronous interface available. Version the contract. Measure failures across clients. The goal is not to chase a protocol headline. The goal is to make your capability portable without making it fragile. Here is a practical 4-step plan. First, map the current product and identify the piece that creates the actual value. Second, ask whether that capability can become a stable, stateless, authorized service. Third, define explicit contracts for long-running work and interactive results instead of hiding state in the front end. Fourth, validate the complete flow with at least 2 real MCP clients. My conclusion is simple. This MCP release matters because AI capabilities are gaining a distribution path independent of a single application. The next valuable AI company may not own the next chat window. It may power many windows from behind the scenes. When a service can be discovered, authorized, invoked, presented, and trusted to finish long-running work, it is no longer just a feature. It becomes portable infrastructure for the AI ecosystem. Follow. See you in the next one.